Hi everyone. Welcome to our first webinar of a webinar series, Smart Transportation in Transition. This is a webinar series that's supported by the Israel Smart Transportation Research Center. And the goal of this webinar series is to present the emerging research, methods, and applications in smart transportation. And we aim to create a forum for discussions on how transportation systems are changing in response to emerging technology, behavioral shift, sustainability goals, policy needs, and evolving mobility patterns. So my name is Ray. I'm a new assistant professor at the Technion, and I'm very happy today to invite Professor Oded from the TU Delft to be our first speaker of the webinar series. And I will just start something brief about Oded. So Oded is a professor of the transportation systems at the Delft, and he's also the head of the Department of Transport Planning, and he also served as a guest professor at the KTH, Royal Institute of Technology, Stockholm. His work mainly develops a lot of theories and models for multimodal passenger transport networks, integrating tools from behavioral science, operations research, and network science. He also co-led the Smart Transportation Lab at Delft, and his research spans topics such as assignment models, route choice models, network design, system resilience, and resource allocation. And he's also the principal investigator of the 3MAS project, an ISTRC consolidated grant devoted to multimodal long-distance transport, and has also held an ISTRC starting grant. So that's a lot to talk about for Oded. And something personal from my side. So I know Oded like long ago when I started my PhD, and he has been very inspiring to my early works on ride sharing and mobile services. And I hope that today Oded will share his opinions and on his new project on this long distance travel. And the floor is yours.
Happy to be here. Thanks for the invitation and the opportunity to share some of our early work in this European Research Council project called 3MAS. And clearly, long distance is relative, right? And I will be talking about long distance travel in the European context. So we'll be talking about some early results from the 3MAS project on behavioral, structural, and policy opportunities and challenges in the context of long-distance passenger travel. And I think many of you also visiting Europe have a good overall impression of international travel by train, but also realizing that there is a lot of opportunity for further improvements. I will first describe some of the problems and issues and then go into some of the solutions. So first, a little bit of context. Of course, climate change plays a large role in motivation for having a shift to rail also in the long-distance travel context in Europe. We're making good progress in achieving some of our climate goals. At the same time, we as a sector, the transport sector namely, are not the front runners, and that's an understatement. So that's one of the few sectors that actually has seen an increase in CO2 emissions in the past decades. Despite a lot of technological developments and having a larger share of our fleets electrified, and this is primarily because of increasing demand, right? So that's something we recognize in urban regional context, but also holds for long distance international context. So the European Commission is committed to reducing the contribution of transport to CO2 emissions. And part of that mission is also having more passengers cruising for train when traveling in Europe. So that's one of the clear policy objectives that they have. If you look into some of the key developments in this area of long distance travel in Europe, and then you should think of non-commuting trips of, say, 100 kilometers or more. So they don't have to be per se international. They can also be within domestic borders. But those are trips that you don't perform on a regular daily basis. But they tend to be either business trips, that's about 20% of all these trips, or leisure, recreational, tourism trips, those are the remaining 80% or so. Some of the trends that we see is that The aviation sector has completely rebounded from the COVID pandemic. At the time during the pandemic, you may recall there was a lot of talk about supposedly a new normal. We don't see much evidence of that happening. So people are back into flying in large numbers, also in Europe, exceeding the pre-COVID levels. When it comes to the train alternatives, it's still cumbersome to find information, book trips throughout Europe when you cross borders. And the European Commission has some plans on improving that, but this is still a work in progress. And of course, geopolitics play a role in this context, from border controls to the impacts of geopolitical events on energy prices. So it's a very dynamic kind of environment, also sort of market dynamics. I will get back to that later. At the same time, there is a sense of urgency to bring about a change. And we see that in terms of attitudes. There is evidence that people are concerned about the environmental impact of especially long distance travel. At the same time, there is increasing evidence that does not translate into per se behavioral shifts. So there is an increasing gap between so-called flight shame, as it's sometimes referred to, attitudes and actual behavior. Then there is also, I think it's fair to say, a sense of disappointment with the quality of service that is currently offered across the continent, especially when it comes to long distance travel, and the discrepancy between people's expectations, those that are willing to try and change to train, and the experience that they gain. On the policy front, there are already some early attempts, some of them already in place. You might have heard of the short-haul flight ban. I'll get back to that later. It was first introduced in France. So in France, at the moment, you cannot offer a direct flight connection between cities where there is a high-speed rail connection offering a service within 2.5 hours time. For example, Paris-Lyon. So that is a more, let's say, aggressive measure to reduce short-haul flights and having people choosing for the alternatives. Again, I will get back to that later. So we see some initiatives already by policymakers to bring about a change in the short term. So if you think about the European context, especially along the so-called blue banana, as sometimes people refer to it, so from south of the UK, around London, through the Randstad in the Netherlands, the Ruhrgebiet in Germany, down to north of Italy. This is a very high concentration of population. But more generally, distances in Europe are not long, generally speaking. They can be connected by rail connections. There is high population density, there is high welfare levels. We even have a supranational organization, namely the European Union. So all of the conditions that you would expect will facilitate the development of a truly European rail network. Yet the reality is very different from that. Instead of having a unified European network, we have a patchwork of poorly connected national networks. That's not me saying, that's the European Court of Auditors. And this is reflected in having national high-speed rails in Spain, in France, in Germany, in Italy, very few cross-border connections, some important missing links, some even differences in technology and track engineering and so forth that create real barriers. So how do we bring about a change to that? Then if we look into the past, say, 2 decades, I think there was a optimist kind of perspective that things will change over time in the desired direction. It doesn't happen by itself. So here is a reflection of that. If you see the different number of trains crossing borders in 2001, 2019, just before the pandemic, actually the number of trains remained unchanged. It did become somewhat faster, and the number of cities connected across borders actually decreased. So business as usual does not guarantee an improvement by any means. There is a need for action for things to change. If you look into the connectivity of air versus rail networks in Europe, that's kind of the first analysis we did when embarking on this topic. Then the network is highly connected by air. So more than 50% of all the origin destinations of major cities in Europe have a direct connection, direct flight. And the remaining can be connected using a single transfer, with less than 1% requiring two. And that has to do, of course, with the hub and spoke nature of the aviation network. So this is a very powerful structure where if you open a new airport, right, and you can offer only one connection, you will probably connect it to Frankfurt or Charles de Gaulle or to Schiphol, because then you know that you'll connect to many other airports with a single transfer. Things look very differently by rail. That's inherent to this different technology, right? But we're talking about under 10% connected directly of all the cities, major cities in Europe, or functional urban areas to be more precise. And about 2/3 connected with 3 legs. But to get anything close to 99%, you'll need to go up to 6 transfers. So that is the real barrier for increasing, having people shifting to rail, because transfers not only in themselves, of course, impose discomfort, but there's also high uncertainty that comes with that. Also different operators, so that's also to do with how this is structured in terms of ticketing and information, who's responsible in the event of delays and disconnections, all of that. And also, we do know that people have a greater reluctance to transfer in a foreign country. They may not know the way, the language, and so forth. Whereas when you fly, you do have a sense that your airline cares for you, responsible, will find a solution. So that's part of the story on the supply side and the transfer. So if we think about the different kind of interventions that one can make in bringing about the change to the current state of affairs. So there is a whole set of attitudinal changes with again, the question mark to what extent those translate into behavioral changes. I will talk very briefly about that. Possibility to do things remotely, that's about potentially having fewer trips, not per se a modal shift. That's another way of reducing the emissions. Infrastructure development, that's of course key. And then there is the multi-decade TNT program you may know of in Europe, which is currently ongoing. And of course, primarily investments in high-speed rail. Service provisions on top of these infrastructure developments, you need to also improve a set of lines and frequencies and capacities that you offer, and also introduce new concepts of service, such as the night train, a long-distance bus. There is some innovation in this field, new international connections, market evolution in terms of improving aerial integration, capitalizing on the increasingly open access rail that we have in Europe. We see some pioneering companies making use of that. And policy interventions, we've seen one example of that, the short-haul flights. I will talk about this, as well as mobility credits. And there are other measures such as capacity reductions and taxations. And finally, there is a whole set of technological innovations that can reduce ultimately the emissions associated with this sector. And here you can think about sustainable aviation fuel, electric airplanes, or more futuristically, Hyperloop. On SAF and electric airplanes, there is a lot of development, also in Delft and elsewhere. And there are some already business cases for short distance flights that could be served by these electric airplanes. And the European Commission also has explicit targets about the share of fuel being sustainable used by European aviations. But I will not cover this part, this technological innovation in this talk. So a whole set of things that can be done. Me coming from public transport, so my perspective on that is you can separate planning problems into strategic, operational, tactical, real-time planning, doing this at different scales, so from long-distance travel to micromobility and everything in between. And doing so requires knowledge from network planning, network design, network assignment, operations research, simulation optimization, and behavioral modeling. All of these components are necessary and also need here to be combined to look into the strategic planning, in this case, of a long-distance passenger transport in Europe. At the same time, there are also some important differences from my previous work, which focused on urban regional multimodal transport. And that is primarily the fact that you don't have a central single planner year. You don't have a regional transport authority that designs the lines and sets the frequencies and sets the prices. Instead, you have interactions between different market players, right? Think about rail operators, but also bus operators and airlines. And they're all free to design their network and set their prices, and they do a lot of revenue management. So you need to have a different approach to model that. What does remain the same is that we need to gain better understanding on traveler behavior in this context. There is a lot which is still unknown, much more than in the urban context. Even simple things like transfer penalties are not trivial. Performing multimodal, multi-layer network assignments, which can then allow us to provide input into a service design optimization problem for each of the single planners, each of the single service providers, then having them interacting in market context and setting prices. And all of that then allows us to find the market equilibrium, which is then also subject to policy interventions, which could be either on the demand side, think, for example, on mobility credits, or on the supply side, for example, short-haul flight span. And ultimately, we want to use this kind of model federation to be able to understand, model, forecast the implications of different policy interventions, which can be oftentimes counterintuitive and sometimes even counterproductive, as you will see. So this is the Free Mars project, started last year. So we are still in early days. It will run for a total of 5 years. The team is in place. We all started, have the research plan. We had a couple of events with partners from the industry and academia to set the ground. And we are now good to go. So I will share work from some previous work as well as early work from team members. So starting with attitudes and behavior, I think there is a lot of hope by many people that change in attitudes will solve much of the problem. And there is, I think, an increasing body of evidence that suggests otherwise. And sorry for reduction in this slide, but I will guide you through. This is from a small study we did a few years ago where we confronted members of a Dutch population with their emission profile, if you wish. So based on information, individualized information they provided on their travel habits and household habits and so forth, we visualized the emissions associated with different activities that they performed. This blue circle, that's their single trip to Bali in Indonesia. The orange one is their year-long commute by car to work. So that puts things in perspective, I think. The red one is the household consumption for electricity. And the fourth is your flight to Berlin. And I think somewhere like 6, if I'm not mistaken, is your meat consumption. So that I think does help things being in perspective. And then we confronted some people with this information, some were not exposed to it, and we wanted to see whether just simply being better informed and more aware will make people make different choices. And we did this estimating structural equation model, and you can see here the different relations we were interested in, but ultimately we're interested in the impact of information on the intention to fly. And there is very little to speak of, as you can see here. Most of the relations have absolutely no impact or very close to it. The only exemptions being awareness on general environmental attitudes, and importantly, the perceived behavioral control has a strong impact on the intention to fly. And that is whether you have a perception that you do have reasonable alternatives to choose from. So that's key, right? And that you have to start with that belief, if you wish, that there are alternatives that you can choose from. So attitudes clearly does not translate directly to behavior, far from that, but also goes for us, transport academics. We are no exception to this rule, I'm afraid. So we also seen with survey on transport academics that the same goes for us. We have good intentions, but there is little translation of that to practice. And this is also the outcome, the conclusion of a large meta-study published recently in Nature Review Psychology, which looked into different kind of environmental behavior, including recycling, for example, and the different effects that were found in the literature. And you can see that beliefs and attitudes and knowledge have very little to negligible effects. It's really access, which is related to perceived behavioral control, that explains much of that. So let's not have high hopes in people changing out of simply goodwill, so to speak, without actually experiencing change in cost, time, comfort, right? The bread of butter of our transport planning. So when entering this space of looking at long-distance European travel, one of the challenges is data. It's very fragmented, just like the network, also the data associated with it. So a first effort that we put, and here a lot of credit goes to Ajat Verma, the postdoc researcher working in this project, for compiling a lot of data from 30 different countries that we are interested in covering here, from 372 functional urban areas that we identified, and more than 30,000 routes. And there are a lot of things that you need to decide along the way. What is an international route? What is of sufficient high speed to be considered, and so forth. But we now have a full rail and bus network for Europe. Important to note that also long distance bus is an increasingly important alternative. So we wanted to make sure we also include that. So we now have these networks we can now work with, and if others are interested, we are more than happy to share. We intend to soon make that public. And we can use this graph construction also labeled with all the relevant information, travel time, prices, frequencies, capacities, to use it for network assignment models. To give you a little bit of a feeling, this is a kind of first analysis of the accessibility offered by the different modes, bus and rail. As you can imagine, by rail, there is a lesser coverage, and with you need more transfers to get to different locations. Bus lines tends to be very long, crossing many countries, really cutting through the continent, and therefore they offer an typically relatively slow yet direct alternative to many destinations. So it's much more point-to-point kind of service. We also look into the accessibility offered by the different modes, and you can see that, as you can expect, the central areas, geographically speaking, are covered, of course, more than others. So you can reach a larger of the European population from these cities within a certain constraints, and for example, the number of transfers, and the more so by bus than by rail. We also complement this with air data. Air data is not publicly available to a large extent, unlike bus and rail. It's highly protected. We have acquired now data that will allow us to construct also this graph for air, including all the schedule, fares, and the passenger volumes data. So that is work in progress. So we'll soon have the complete multimodal network, bus, rail, car, as well as air for the European context. But we already have some analysis that we have made, that I would like to share with you today. And I will start with policy interventions, because that is, I think, are, again, high hopes in some of those bringing about a substantial change. And we wanted to evaluate the potential impact of those. So let me start. I will cover three. I would like to start with air-rail integration. So the idea that you could improve the connectivity between rail and air in intermodal hubs, right? So airports that have a major train high-speed rail station, only using existing connections. So that does not involve any further infrastructure developments. And for trips within Europe. So a lot of this, I think, makes sense for trips which are long-haul flights. For example, taking the train to a nearby well-connected airport and then flying, say, across the Atlantic. But here is the focus within Europe, where it can still make sense. So we saw that 50% of the ODs still require transferring. So maybe for one of these legs, you could take the train. So that's the idea. And we see some initiatives by market players already, where airlines and rail operators work together to offer joint products. So we first we reviewed basically all the airports in Europe and identified the rail connectivity that they offer, classify that, and then use that as a point of departure, because again, here it's based on the current supply. And then we came up with a simple and I think sensible indicator, which we call the Air Rail Integration Substitution Potential, ARISP. And of course, it's a function of the passenger flow, so how many people go between these airports or cities, and then the ratio of travel times between air and rail, where you account for all the waiting times, the border control, everything that is part of that, transfers, you name it. And we have here a coefficient that reflects that there is large empirical evidence to suggest that people perceive more negatively their travel time by plane than by rail. I think we can all relate to that. It's much less useful and comfortable time spending on the plane. So with that, we can identify which city pairs, airport pairs are potentially most interesting for potentially substituting part of a trip by rail. And when we apply it to the entire European data set, here is just an illustration of the top 25 most promising one based on this indicator. And you can find here the ones which have very high passenger volumes, right? So that's part of that, as well as ones that are well connected by rail, right? So that they cannot be too far away from each other for rail to be a reasonable alternative. And you can see that it's very much, of course, reflects the current high-speed rail network. And we can do that for all origin destination pairs in Europe and find out which OD pairs are most promising potentially for rail integration. Here is the percentage on the x-axis increase in travel time, and you can see that it goes very quickly into unreasonable increases. So we considered here that the most passengers will be willing to substitute one of their air trip legs with rail if it's doesn't take more than double as long. And if you do that, basically put the cutoff here in 100, so quite low here on the graph. But still, it will cover, for example, Barcelona, Madrid, and Berlin, Frankfurt, so some of the largest volume OD pairs. But you will get no more than 1% of the total European air trips potentially substituted by rail. I don't know how about you, but I found this quite underwhelming. And that's not trivial, right? How do you get all these people that do make a different choice at the moment to make an alternative one, which we find desirable, without making serious improvements? So that was one first result that made us then think, okay, what about more aggressive measures, if you wish? What about if we ban short-haul flights altogether? And we have already the French example. If one was to implement it at the European scale. So imagine that you use this 2.5 hours, or maybe even more. Maybe you say you cannot even run flights where you have up to 5 hours alternative by rail. How many flights will be affected by that, and what would be the environmental impact? Is there an argument for it? So that was the drive for this second study here. And what you see here is also different cutoffs in terms of what is the rail in-vehicle time that you consider to be used as the threshold for this policy. And what you see here are the impact of both full ban, and a full ban means that you cannot run any flight points between this origin destination. A partial ban is actually what is in place in France. So you do have some flights flying if we're going from Lyon to Paris nowadays, but you can only get a seat on it if your destination is elsewhere. So you can fly from, say, Lyon to New York via Paris. And the reason for this is that the French government is concerned, or Air France, and therefore the French government, but otherwise passengers will go from Lyon to Amsterdam and then onwards to New York, right? So that's a partial ban. And what we see here is that in terms of travel time gains, there are some to be made for the short range. In terms of environmental gains, there is some argument for extending this to 5.5 for full bans and up to 6.5 hours for partial bans. And of course, that doesn't hold to every single case, but then this is when we assume that you apply a threshold, then you apply it blindly for all connections that fall within this range. We can also look, of course, geographically, which connections are affected and which ones are better off or worse off in terms of societal welfare, where we put a certain monetary value on CO2 emissions reductions and on travel time savings. And those tend to be relatively, again, short connections, but you can see that where you have good high-speed rail alternative, for example, Amsterdam to London or within France, then this has more benefits than if you do so between connections where there is a poor alternative, right? And again, we can use this kind of plots to identify origin destinations that will benefit from that or not, from a full ban or a partial ban, and also seeing how much of an impact it will be in terms of travel time increase or decrease and CO2 emissions reduction. So let me use an example here. Let's take two OD pairs, one being Paris-Nice, and the other one being Frankfurt-London. If you look at the full ban, they are both at this gray shaded area, part of a graph, which means that the travel times increases cannot be justified by the CO2 emissions reductions. Once you move to partial ban, then they both just move into the acceptable range because then the CO2 reduction is somewhat, well, they are lesser, but also the travel time impacts are lesser. So then we can identify which origin destination pairs there is potentially a societal argument for introducing a short-haul flight ban based on these impacts. Again, I find the result as a whole fairly underwhelming. If we introduce a partial ban like they have in France in place for 2.5 hours, that's exactly what they have in the French case, then Europe-wide we get not even 1% reduction in CO2. Simply because there are fairly few also connections that fall within that range. If we go for a very drastic full ban and up to 5.5 hours by train, which for some people that's questionable, then we're talking about a significant reduction, but that's politically much more challenging, of course. And when we're talking about 10% or so. So also important to mention that there are a lot of potential risks associated with this policy. First of all, we assume that then if people don't take the plane, they take the train. It's not that there is, an infinite capacity on our railway infrastructure. It's already been challenged in some places. So you have to see whether you can accommodate those. Also, you free slots at airports. Actually, some airlines are really working hard to get some of these short-haul flights cancelled and operated by trains. Because then they get more lucrative slots that they can run long haul, which is for them more interesting. So, and then emission-wise, of course, you haven't achieved your goal, if that is indeed the goal. Also, people can make different adaptations. They don't have to change the rail, right? They can switch to the car, or they can travel through, say, Istanbul, or they can change their destination altogether outside of the perimeter of your policy. And we can have, as therefore, all kind of unintended consequences like carbon leakage. So it's far from straightforward with those things, how to mitigate some of these potential risks. So we saw aerial integration and we saw short-haul flights ban. The third policy I would like to cover is our tradable mobility credits. I don't know how many of you have heard of it. It's a somewhat potentially less known concept. So I'll briefly introduce it. The idea, first discussed in urban context, is that all residents of a city, for example, get a certain amount of mobility credits that is assigned to them. It can be uniform, everyone gets the same, or depending on different parameters. And then you are free to use it for your travel. And how many credits different travel requires depends on the distance and the mode to reflect the externalities associated with travel. So ultimately, emission is an important part, not the only thing, of course. And when I was introduced to the topic, I thought that actually makes most sense, if anywhere, in the long distance context, because this is less habitual. This is one where it's a lot of the trips are not mandatory, and it's also one where it's easier to potentially implement, because a lot of this can be conducted through ticket sales for air, rail, and bus. So imagine that all EU residents get certain amount of credits that they can use, let's say, per year for their long distance travel. And the number of credits associated with different travel depends on the emissions. So it depends on the distance as well as the mode that they use for the travel. And those are tradable. So if you consume less than you actually need or spend, if you have more than you actually consume, then you can sell it in the market. If you need more, if you want more, then you can buy those in the market for market equilibrium price, right? So if you think about it, unlike tax is something that you know upfront how much more you charge, right? Let's say per kilometer, but you don't know upfront what will be the outcome, because people can, of course, change their behavior. That's what you hope for. Here it's the opposite. You guarantee actually a certain emission, because people cannot spend more than this total amount of credit altogether. But what you don't know upfront is what will be the price, because that is something that emerges from the transactions in the market. So we wanted to study that and see how this could potentially work. We had a model where we looked into the transport market equilibrium as well as the credit market equilibrium to establish the price of credits in the market and the potential impact on travel choices. Doing this for the European context for long distance travel, here are some of the basic facts of the case study we looked into here. And we use current travel times and prices and so forth. And we found out that the credit price that will emerge in the market, if you are to set the number of credits that you distribute in Europe so that you meet the Paris Agreement objectives of 30% reductions by 2030, then we are talking about a price of 272 euros per ton, which is very close to actually the market price that we have for CO2s in the current scheme where the polluter pays in Europe, where it's also a market for their emissions. And you can see that, as you can imagine, some countries, think of Norway, Luxembourg, Switzerland, they need or choose to consume much more credits than initially assigned. So they buy in the market. They have, of course, a higher value of time, higher purchasing power. We account for that in our model. So we see it back in the results. Whereas Central Eastern European countries and Portugal, they reverse. So they make financial gain, people in these countries, right, from the fact that they spend fewer credits than the average European. And to give a little bit of an idea what does that mean in terms of money, if you go from Amsterdam to Zurich, then you will have to pay extra 21 euros by air, 21 euros equivalent in terms of the credits that you will use. Maybe you don't have to pay anything because you don't exceed your credits, but it's equivalent to 21 euros in terms of the value. By rail, only 4, by car, 24. So that gives a bit of an idea on how credit prices could work. Here are the results in terms of modal split. So you see, without mobility credits, it's about 50% of trips taking place by air, 23 by rail, 27 by car. And if we look at the base case here, you see reduction in the share of air, as you can imagine, a slight increase in the share of rail, decrease for car, and interestingly enough, because we allow for it in the model, 20% of the trips get cancelled. And that's a more difficult part to like, is this, you can debate whether this is desirable, right? What is the loss reflected by that? So that's important to bear in mind. We did look also into scenarios where aviation and car fleets become more sustainable, which is already happening with SAF and a larger share of the fleet being electric. And if that is the case, then you see, of course, increasing those modes compared to the base case and fewer trips being cancelled. You can also look at it in terms of different distance categories. We know that rail is most interesting in the mid category because, of course, flights are much faster for longer distance and cars for shorter distances because you don't have to wait and transfer. So that is expected that also the increase in the modal share mostly happens in the mid-range category. And this is in terms of modal share, but you can also look in absolute numbers where you discard the cancelled trips. And this is much more, of course, noticeable. So we see these large decreases in air volume, especially for longer distances and mid-range as well. So the longer ones tend to be cancelled, the mid-range tends to be substituted. That's an important difference. Another way to look at the results is using this triangle to make it a little bit more concrete. Not sure if you're used to seeing this kind of visual. So this is how you can reflect a modal split for 3 different modes, being air, car, and rail here. And if you're at the extreme, any of these corners of a triangle, that means that all people travel using that mode between these 2 cities. And the size of the circle corresponds to the volume. So we see that, for example, Madrid-Barcelona, which is very large volume, it's very well connected already by rail, yet there is a sizable share going by air. It will move further to the rail corner if mobility credits were in place. The same goes for Amsterdam-Paris. But you can also see cases like Paris-Madrid, 2 of the largest cities in Europe. Practically everyone travels by plane. They're very poorly connected, and then it will slightly shift down, but hardly any change to speak of. So key takeaways from these different policy interventions is that, well, the first, the short-haul flight ban and the air integration, very moderate results. And especially the short-haul flight ban and the tradable mobility credits will require very important political efforts and trade-offs to be made to compromise connectivity. Aerial integration is less debatable, but much slimmer impact. So ultimately, we do need also to work on the supply side. It's not sufficient to introduce such policy interventions on their own. We really have to do some work on the supply side, and this is what I would like to cover within the remaining few minutes. So what can we do in terms of improving the actual offer? And night trains have seen a revival in the past 5 years or so in Europe. And some people think that there is a lot of potential in it. I'm over skeptic. I think it's an important product, part of the whole picture, but it's as a limited market. It's a fairly niche product. Sometimes you see this kind of network maps, but it's effectively not a network. No one is going to transfer between different night trains, right? It's not the intention. So it's quite limited in this regard. It's an excellent experience, but it has limited capacity also because you can fit fewer people into these trains and so forth. So that aside. We do see some early indications on an uptake in terms of new lines being introduced, largely thanks to this open access rail policy, which is now in place. So here are some of the latest news from Prague to Copenhagen. Now work being placed to connect London to Zurich and Geneva directly. So there is some progress and some signs of this getting traction. But we asked ourselves, how would ideally a unified European network look like, as opposed to the current fragmented state of affairs? So we had an optimal rail network design exercise for Europe, had to develop different kind of heuristics there that ended up with the following kind of assumptions. I will not dwell on that. We had to estimate the demand. That's always a challenging part because there is no public source for that. So we had to make some assumptions. And we looked into 2 different scenarios. One where we strictly plan for maximizing the economic outputs in terms of supplier and consumer surplus. And one where we call it extensive, where you also monetize externalities. So when you take kind of a societal planner perspective. And we ended up with this map, deliberately making it metro-like map with different lines reflected and the corresponding frequencies shown with using different thicknesses. And it's not that we argue, this is what we should go for, if I'm to talk to policymakers about that. But I think it's a kind of a useful point of reference in terms of, okay, if how far we are from such a potential reality and where are the main gaps. And important to note, even with this idealized network, which will require remarkable investments to enable it, we are still, just to have 2 feet on the ground, we're talking about a model split of which will double roughly to 25 to 30%. So, plane will remain the dominant mode even in that reality, because it has simply so many advantages in terms of flexibility, in terms of speed, in terms of connectivity that is impacting its model split. We were curious about how can we get there, because this is this kind of idealized picture, but how can we get from the current state of affairs to this potential idealized network? So we also looked into having an iterative evolutionary model, which also takes into account civil engineering factors, different costs of tunnels and bridges that had to be built in different topographies in Europe, crossing rivers and all that. And by modeling this, we could see how the network will potentially evolve over time, up to 2065. And also what would be the main breakthroughs in terms of connecting the network. And I think that's an interesting insight there, that you build links first that on their own right may seem to make little sense, but then at some point they start connecting sub-networks that otherwise are not connected, allowing much more people to travel between different origin destinations, and consequently also increasing the modal share of rail over time. So these kind of tipping points, if you wish, are clearly visible in this network evolution. And then we also contrasted our results with the actual plan of the European Commission, so the TNT that I mentioned earlier. And we can see that there are quite a lot of points of where they resemble each other, which is, I think, reassuring. But also points where they differ. And it can be justified. There are political considerations about coverage, right? So all countries in the European Union should buy into this plan. Also some geopolitical reasons for some of these lines. But I think the main difference is that the model aims more for a well-connected core, and the European plan is more aiming for coverage. So you can see this back in some of the decisions made. Again, this will about double the share of rail if this was to be realized. So let me close with saying a few words about our ongoing work and focus. One is going beyond mode choice, which, as you've seen, was much of a focus, looking into destination choice. That's an important factor that can actually potentially even have greater effects, I think. This image that you see is from a social media campaign that Deutsche Bahn ran a few years back. I think it was quite brilliant based on your search for the travel destinations. They created 2 images, or found 2 images. One at your destination, saying the Grand Canyon. And you can see how long it will take you to get there, how much it will cost, how many emissions will associated with this, and found a similar as possible picture in Europe, in Germany in that case. You could travel to and contrast these two. And then, you question, do you really have to go that far and pay that much for that experience? So I think there is some promise in that. Another point on our agenda is looking into multi-period service design. So the same like we saw for the infrastructure development, also for service design, how do we move decade by decade in a way that we have the least regret, so to speak, as we progress. Multi-operator competition. So they compete, but also cooperate. We see that between airlines in alliances very clearly. Fair distribution models, but also increasingly between airlines and rail operators. And finally, robust decision-making. And we can all, I think, relate to the fact that we now live under deep uncertainty with geopolitics, with extreme weather conditions, market dynamics. All of these impacts, and policymakers need to make decisions for decades to come. In this case, investments. We're looking not, of course, into a single future scenario, but considering many different ones. Also, in terms of how quickly different technological innovations will take place, there's also quite some uncertainty there. Most welcome to make use of the datasets and software that we built and developed. All of them are publicly available, and I'm happy to hear back from any of you if you're interested in more details on any of these works. Thank you.
Thank you so much. It was a very inspiring talk. Thank you, Oded. So now we're open for Q&A. So I think you can send through the chats, and then we will, if we have any questions. So meanwhile, maybe the audience can prepare some questions, and I have one question from my side.
Sure.
So a lot of a concern of long distance travel for mitigating or modal shift from air to train was from the emission perspective, right?
Correct.
And if I'm not, if I remember correctly, so European Union now they are also having this ETS2, this tradable scheme
Yeah.
that would kind of cover the transport sectors. And from your point of view, what will be the impacts on long distance travel? Because if the travel credit was applied, then this kind of cost will be transferred to the passenger side. Will they play a role in helping transfer to uh, rail travel?
Yeah. So the ECMS at the moment is only applicable for the transport sector manufacturers. So the production related emission costs. So not yet for transport consumption. So that will be the tradable mobility credits will potentially do that, and we see that it will have some. I think from the three policy instruments that I covered, this is the one which is the only one that guarantees that you will achieve your climate goals, right? But of course, there are other challenges associated with it, acceptance, political, some implementation challenges as well. But I think those are fairly limited in the long distance context. But I maybe more generally about this point, I think that the discussion should go beyond the environmental dimension because car fleets are becoming increasingly electric. We expect them to be all in Europe by 2035. And if I take the example of Amsterdam, Zurich, that was shown in one of the slides, that will actually mean that cars will be less polluting than trains for this trip by then. So the argument for trains should go beyond only the emission reduction. So it should be also ultimately be about accessibility. And I sense this is a somewhat forgotten kind of perspective on that sometimes in the current debate.
Yeah. So we have also one question from Hiel. So he's asking, can you say something about travel demand management versus taxes? Does it shift uncertainty from the government to the individual travelers?
That's a fair point. Well, I think uncertainty is in both cases there. So for also in taxes, for the government, there is also the uncertainty about the tax collection, right? So you cannot just simply assume I take the current demand, apply a tax, and this is my revenue, since obviously demand will change as a consequence, which is the exact goal, right, of introducing such a tax to start with. So you can try and forecast that, but there is uncertainty there. I can give as an anecdote an example that in Stockholm, when they introduced congestion charging, which is not very different, they first exempted hybrid cars because they wanted to stimulate people getting those. After a few years, they became so many that they had to remove the exemption because they didn't get the kind of tax collection that they were expecting. And it also did not have a behavioral consequences because then people could travel for free during congestion, which is a lot of objective, right? And too many of them. So it became counter-effective. So you can see that uncertainty is there also when it's in the form of taxation.
And the next question comes from Shlomo. He's asking, how do you account for travel times from and to the airport? And from personal, I want to add to that, like a lot of time we spend also in the security, right? So security checking, and there's a lot of uncertainty. And how does it is accounted for in the models?
Yeah, so good point. So we have two different things to make a distinction between. One is what you point to, Ray, which is the time spent at the airport, which is a fairly good estimate for this. There is some distribution around it. It does differ, of course, between more like low-cost airports that you have quite a bit in Europe, right, and larger ones. But the point made by Shlomo is about the access time to the airport, if I understand correctly. And that is a more subtle one because you see it in some studies as they make the mistake, in my view, that they take the centroid of the city and then they use this as a point of reference for accessing rail and airports. If you do so, you get by design a systematic preference for rail because the train station tends to be located in the city center, the airport in the outskirts, and most people don't start the trip at the city center. So the approach that we take is that we put a grid on the functional urban area, which is typically quite large. There's a European definition for it. It's a commuting area, so to speak. And then you have a population associated with each of these grid cells, and you calculate the access time from each of these grid cells to the airport and from each of these grid cells to the train station, and you basically you take the weighted average of that. So then you get a better reflection of the actual access or egress time of individuals to airports. Definitely at the origin. At the destination, you can start debating whether most people then travel to the city center, because that's where most destinations of travel are, or also onwards to the countryside. But on this, I haven't seen much work.
And then I guess that's the final questions from Jack. So he's asking regarding the behavioral aspect, how prevalent is the flight shame across Europe? And to what extent does it really influence people's travel choices? And can this behavioral tendency be incorporated into, dynamic demand management policy?
Yeah. So flight claim is a concept that started in Sweden, to my knowledge, and then expanded elsewhere. We see that there is a fairly small group that can be described as people that experience flight claim. Like in many topics in Europe and elsewhere, society becomes more polarized on these issues. So there is a group of people who experience that, and again, we see little evidence to suggest that this translates to behavioral change. So the question is, if you feel guilty about what you do, how is it put into good use, so to speak? At the moment, it seems that it just creates a discrepancy between what you think is desirable and what you ultimately do. And we can try and reduce this discrepancy, but it seems that to do so, we need to offer a good alternative for people to choose from. At the moment, I will not argue for incorporating this into behavioral models simply because there is the link between these attitudes and behavior is too weak for us to account for.
I think the analog is from SP and RP, so what people say and then what they actually do.
Yeah,
So
but this is stating your choice. Here it's not about even stating your choice, right? That's not where the gap is. It's between what what you think is the desirable right way to behave,
yeah,
right? So that's more between values, right, and behavior, and that's not dismissing it. I think it's real. And to me, that is a reflection that there is a growing discrepancy between what people hope that they will be able to do and what the current network allows them to do. And it's for us to close down this gap.
so I guess here we conclude the seminar. And thank you, Oded, for very much for the interesting talk and a lot of insight for your project on how to promote long distance travel and to have a model shift to promote more sustainable travel.
Thank you, pleasure.
Thank you.
Take care, everyone. Have a
Take
good
care.
summer.
See you.